All right. Let's see who's all here. Perfect. Got three people here already. See who these three people are, and then we will go ahead and get started. Oh, okay. So I did have a few people that I responded to remind. So we're gonna give everybody a minute. For those of you that are joining us, I'm using Remind because when I convert your phone numbers to emails, I'm noticing that people are getting the messages cut off. And um, because this class is only going to be about a month long and people are busy working, I know that you're not going to benefit as much from seeing those cut off messages. Because when I do that for my normal classes, the parents already know the kind of messages that I'm getting. And if it's cut off, they'll usually send me another message or I can find a workaround. But I know that this situation is very different. Okay, much better. Squirrel. Okay. All right. Okay. So make sure that you sign up for Remind. I'm going to send out a link here for it. So far, I have had 9 people join. Okay. Which is good. Um, Probably still use a few more people. Bear with me. I'm gonna find a link to send to you guys. And today we're going to be talking about fractions in algebraic equations. Pretty much everybody here was a 4 or 5, and with the previous class, I have been working on equations. And what I've noticed is that algebraic equations are the majority of what the algebra portion of the test consists of. And it's also what people struggle the most with in math when they're thinking about what's intimidating. I'm going to be getting some more resources to kind of help guide us through that. But that's what I have seen based off the test scores and my experience so far. And if you would like, as I'm setting out this link, if you'd like to join by conference call, please let me know. I'm going to do my best to call everybody, send messages so that we get as many people on here as possible. Okay, so that's not it. Okay, and one more person join us. Okay, good. So we got a couple of people on here. Be setting out that message here. We have 9 people that had joined, so I'm going to stay on top of that. Also, I had sent out a link in an email for the Khan Academy lesson on how to solve one-step equations with fractions. As we're working through this, if I see that people could benefit from the conference call, up with the number up there. It's also on the website. Also, make sure you go on the website and fill out the attendance sheet as well. Okay, they'll be there. Sorry, my apologies. It's taking a little bit to load. A moment. Yeah. So the link I'm going to be sending for everybody who is here is a way for you to join Remind so that I can send you a text message when I'm about to upload a video. I know it says I'm only available through email. That's just them. Again, this is just an easy way I found to communicate with everybody so that we can all stay on top of what's going on. So if you're watching this and you have not signed up for Remind, please do so. I can let you know who I have signed up so far. So far, I have Alma, Andre, Brandy, Coral, Diane, Elizabeth, and let's see. I don't think it's gonna let me scroll. I think that might be it actually. It's not letting me scroll any farther. Yeah, it looks like that is it. Oh, I'm sorry. And also have Vanessa Sam. And so if you don't hear your name as one of the names that I've called out, then please let me know so that I can ensure that you guys get in the know. So many things change with this program on almost like a daily basis. Uh, there's one more person besides Vasanya Sam. Nope, looks like that's it. Okay, so let's go ahead and get started. and let's look at understanding fractions. Okay, class code. Send you the class code right now. There you go. If you have not joined, there's a class code as well. Okay, so what we're going to start off with now is an easy way to look at fractions. I know that people hate fractions, so I'm going to start off with a very quick guide to fractions, and then we're going to jump into multiple step equations. Okay. So, in the live chat, please respond with what you know about fractions, right? So, tell me, what is a fraction? What is a fraction? So, I'm just cleaning my screen here. Please respond. What is a fraction? Ooh, I like that. So, you responded with part of a whole number, not a whole number. Okay. All right. Still haven't heard from Andre. Still haven't heard from Brandy. Still haven't heard from Mariana. Still haven't heard from Diane. All right. So if you don't respond, you get called out. We want this to be interactive. I don't want this to be something that's played in the background and then people forget about it, because this program is incredibly important to society as a whole. There's a lot of money that is allocated. So I'm still waiting to hear from those people. Still haven't heard from Mariana, Coral, Lillian, Andre, Diane. There we go. Okay, perfect. Thank you, Andre. So let me know, what is a fraction? Good. Okay. So now I'm getting more responses. All right. So there's a couple of things that I want you to understand when we're making fractions equivalent. Um, and then we're going to talk about dividing and multiplying fractions. I'm not going to use a model for each one of these because we're past the point of really need to spend a lot of time to conceptualize it. We really need to pass this test and get comfortable with working with fractions more than mastering every model that we need. Okay. So, what I'm going to do now is I'm going to show you a model of what a fraction is and what we are really doing when we're making the fractions equivalent. Um, we can talk a little bit about dividing fractions depending on how everything goes. Okay. So, when we have when a fraction is a piece of a number. So let's look at, for example, a half. Well, this represents a whole. This box represents a whole. This is called an. This is going to be called an area model. Literally, because you're doing length times width, right? The formula for area is length times width. You don't have to memorize that, but that's why this is called an area model, because I'm making a model and I'm going to multiply length times my width. And you'll see where that comes up later. So in my model, if I want to express a half, I can partition it down the middle, and I'm going to shade in one side. This now represents 1/2. Now, if I want to add, let's say 3/4, and I'm keeping nice simple numbers, here's what we're really doing. We're going to represent 3/4 as a model. So I'm going to partition it. I'm going to cut my model 3 times. Now I have 4 pieces. Out of these 4 total pieces, 3 of them are going to be shaded. Okay? And actually, you know what? Let's make it even easier. This is going to make it even easier to follow. So let's partition horizontally. 1, 2, and 3. You don't need to create this exact model, but it's going to help you understand what a fraction is. So when we're doing these equations and you're getting word problems and you're wondering how to represent a fraction, you'll understand. This will also help you understand what decimals are and why decimals are also fractions. So this will be a real quick lesson here before we get into the equations. So notice that the numerator, the number on top, this represents what is shaded. The denominator represents the pieces that I need to have a whole, right? If I were to shade in 2 pieces here, I would have 1 whole. If I shaded in all 4 pieces here, I would have 1 whole. Obviously, I can't add these together because they're not the same. And I know in school you were probably taught to do crisscross applesauce, you multiply across, and that's what we're going to use. That's called an algorithm. So if you have kids in school and they say things like, Mom, you're solving it wrong. Dad, you're solving it wrong. You're using the algorithm. Basically, an algorithm is memorizing steps. It's like what YouTube does if you put on a song like Despacito or something, and another song comes on after it. The only thing YouTube is doing is just repeating the same type of sound, and the artist who worked on that song, they find other artists that have worked with them and just repeats that process and keeps playing music. It doesn't understand what you like, it's just repeating steps. We will use that on the test, but when it comes to word problems and algebraic equations, it's also important that we understand why we have to do that. These models show us why we have to understand what a fraction is. This will help us tremendously later on, right? So how do I make these fractions the same? Obviously, the models show me they're not the same, is by bringing over my cuts, my partitions. So I have 3 cuts here, so I need to bring that over and cut 3 times here in the same direction. I had 1 vertical cut here, I need to bring that over and cut here in one direction. Now I've actually made them equivalent. Now, instead of being out of 2 pieces and out of 4 pieces, it's now out of 2, 4, 6, 8. It's now out of 8 pieces. Out of 8 pieces. Now all I have to do is look at the number that I have shaded. I have 1, 2, 3, 4, 5, 6 shaded. Here I have 1, 2, 3, 4 shaded. Now that they're the same, I can add them. And I get 10/8. Right? Let me stop right there before we start talking about improper fractions and mixed numbers. Questions? And if you want to use the conference call, because I know we're going to be talking about a lot, send me a message and we'll use the conference call feature. So if there are no questions, please respond with no questions. All right. Okay. Perfect. So what you see here, this is what is known as an improper fraction. Why? Because the numerator is bigger than the denominator. Some of this is going to sound like review, but again, when we're working with equations, you have to understand not only what a fraction is, but what you prefer to work with. There's going to be moments where an improper fraction is going to be easier to use. All right. There's also going to be moments where you're going to want to use a mixed number. Yes, so you can simplify it by 2, right? So you can divide 10 by 2, which would give you 5, divide 8 by 2, which would give you 4. But you'd still end up with an improper fraction. So to help understand what an improper fraction is, let's look at our model here. So let's erase all of this. We know the answer is 10/8. So we know this all equals 10/8. So this is going to help you understand what an improper fraction is, right? So if I brought over all of my shaded portions to one model, so I'm going to move this one over, I'm going to move this one over, I'm going to move this one over, and I'm going to move this one over. Well, what am I left with now? I got rid of this one. I got rid of this one. I got rid of this one. And I got rid of this one. Well, I have one whole, right? And what's left over here? 2 out of the 8. So this is the exact same thing as this. Now, am I going to do that every single time I want to change an improper fraction to a mixed number? No. I'm going to show you an easier way to do that. But I want you to understand the concept, okay? Especially again for algebraic equations so that you know what each number is. And this is going to be especially important for word problems because if this was like buses and people on a bus and moving over and how many buses would you have and all of that, this is going to be easier for you to understand. Okay. So does anybody not understand how 10/8 as an improper fraction now became a mixed number? Questions on that? Oh, I like that. I can tell Brandy's paying attention immediately. Right in the live chat, no question. 7 heard from Andre, Lillian, Diane, Mariana, Ildi. There we go. Here we go. Got it. So now that we understand that concept, you understand what a fraction is. It's the same thing. So that's going to help you with adding and subtracting. Obviously, if they're not the same, we don't have to do that. So I'm going to show you now for improper fractions and whole numbers. For improper fractions, how to, using the algorithm, these steps to change it. And then we're going to jump into the equations. Okay. So 10/8. If you really want to do this the most efficient way, again, now that we understand the concept, you could say, okay, 8 times what number can I add to get 10 into the numerator? And here's what I mean by that, right? So I have to multiply my denominator by a number that when I add it to my denominator is going to give me 10, right? So this plus my whole number and my numerator needs to give me 10, right? So how would I do that? Well, 8 times 1 gives me 8. And then 8 plus 2 gives me 10. See? So 8 times 1 equals 8. And if I add 2, I get 10. Right? So that's how I know that 1 and 2/8 is going to give me 10/8. That's one method, right? Again, this is just memorizing steps, right? You take your denominator, you look at what you would need to multiply your whole number by and add your numerator by to get this number. That's one method. If that's confusing, I'm going to give you another method, right? So that's method one. All right, the second method is you can simply divide it, right? So how many times does 8 go into 10? Well, let's see. 8 times 1, let me make this a different color so it's easier to see. 8 times 1 is 8. What do I have left over? I have 2. So 8 can go into 10 one whole time with a remainder of 2 out of the 8, right? Oh, great question. So somebody asked, when would we need to use a mixed number as a fraction? Or we would never put a mixed number over a fraction, but I'm going to kind of translate that question. So a mixed number is, think of this as one thing on its own, and an improper fraction is another thing. Why do we have that? Sometimes it's easier to work with, right? And sometimes a mixed number is going to be easier to work with. So if I'm talking about, let's say, buses, right? And I were to say something like, or even like shoes in a box, anything that has to fit into like a container, I could say, hey, this box only holds 8 shoes, or this bus can only hold 8 people. You have 10 people that need to get on the bus. So I could express it as 10 people need to get on a bus that can only hold 8. That's improper. Or I could say, wait a second. If the bus holds 8 people and I have 10, I can fill up one whole bus, right? And then get another bus where the other 2 people could fit. Those 2 people could fit on the other bus that holds 8 people. So that's why we like to play around and move the numbers around, right? Now, if I were to say, hey, I have one bus that holds 8 people, and I have 10, I have another bus that holds 8 people, but over there I have 20, well, then it might make more sense to make it into a mixed number. Or it might actually make more sense to keep it as an improper fraction. It all depends on how we see the problem. That's why, as we jump into these one step equations, it's important that you look at these and understand not only what they are, but which one you prefer. Which one's easier for you to work with? Is it a improper fraction or a mixed number? Right? And the answer to that is your own preference. I would argue there's some problems. Obviously, an improper fraction would be easier, or obviously a mixed number would be easier. But again, that's individual preference. All right. So let's go ahead and move on to very quickly multiplying fractions and dividing. Then we're going to get onto that algebraic equation. We're going to move on to algebraic equations. Okay. So when we're multiplying fractions, and again, staying with simple numbers, okay, there are models we can use for this. I'm not going to get into them. They're not going to be useful. You understand that 1/2 looks like this, and you understand that 3/4 looks like this. Everybody gets that concept. I don't want to spend too much time on that. What I would like you to know is why we can play around with some of the things we can play around with. Okay. So when you're multiplying fractions, you just multiply straight across. Okay. There is a model for this. I'm not going to get into the model. But what I will tell you is that this is going to be the most helpful when we talk about dividing fractions, right? So if I say 1/2 divided by 3/4, because I know that when we multiply, we go straight across, I can use that same concept. This is like inverse thinking, an inverse operation. I can use that same concept to say, well, if I need to take a half and divide it by 3/4, why don't I just switch this around? This is going to be called the reciprocal. This is going to be 4/3. And now what I'm going to do is just multiply. Because now I know, because it's the opposite, that I could multiply across. Okay. So that is called using the reciprocal. I'm just flipping the fraction. All right. And that allows me then to take it from a division problem to a multiplication problem, but still get the right answer. This is all the tools we're going to need before we start getting into the equations. Any questions? Giving everybody a moment. I know we talked about a lot. Okay, got a couple of those. Okay. So it looks like we're going to be ready to move on to the one-step equations. So we're going to talk about the fractions. I'm going to throw in a couple of those. Then we're going to throw in decimals. And then I'm going to show you how you know that fractions are also decimals. Decimals are fractions. Will you want to change fractions over to decimals sometimes? Yes. Will you want to change the decimals to fractions, fractions to decimals? All of that are going to be additional tools that you're going to have. So yeah. Got it. So let's look at 3/2 plus b equals 7/4. Multiple things you guys can do here. And again, if you want to use a conference call feature, please let me know. So once you think you've solved this, if you can, shoot me a text so nobody else sees the answer. That's fine. If you can't shoot me a text with the answer, send it in the live chat. But I want you to solve this, please. Okay. Oh, very nice, Oldie. Okay. There's gonna be multiple ways for us to use this. Now, I'm sure some of you guys ended up using mental math and you quickly said, okay, well, let's look at both of these. 3/2, 7/4. And you said to yourself, well, let's make these fractions the same. Some of you might have multiplied across, although I think most of you, by the fact that we're in a lot of questions, probably said, well, let's make this fraction equivalent to this one. So we're going to multiply by 2. So we have the same denominator. 2 times 2 is 4. If I do it on the bottom, I got to do it to the top. So now this becomes 6/4. So the question is 6/4 plus what is going to give me 7/4? I would say here, most of you would know that this would have to be a fourth. If you weren't sure, you could use inverse operations, meaning you do the opposite to cancel out everything but the variable meaning the unknown number. So you could say, well, I want to find out what b is, so I need to take this positive 6/4 and subtract it. So now it goes away. I subtracted 6/4 here, which gives me 1/4. So b equals 1/4. That's one method, okay? Before we move on to another method, anybody have a question about this? How we got 1/4, the method I just used. And if you don't have a question, again, respond, no question. One person says no. Correct, Ildi. Same thing, right? No. All right. And somebody said, Ildi said, is 25 the same thing as 1/4? Well, you can think of it as money, right? And think of it as money. 25 plus 25 plus 25 plus 25, right? That's going to give you 1/2, right? You could also convert it over into a fraction. 25, so this is the tenths place. This is the hundredths place. So this is 25 out of 100. Right? So if I were to simplify this by dividing by 25, I would get 1. Divide by 25, I would get 4. 1/4. Okay. And again, let's move on. Never mind. Okay. So that's one method. Now, could we have made these into mixed numbers? Well, let's see. What would 3/2 be, or 3/2? What would that be as a mixed number? Still waiting on you guys. Let me know. What would be 3/2 and 7/4 as mixed numbers? Okay. So let's say you want to turn these into mixed numbers, right? Well, 3/2. All right. That's going to end up becoming 1 whole and 1/2. Why? 2 times 1 is 2, plus 1 is 3. That's 3/2. Or how many times can 2 go into 3 evenly? This is now going to then become 1 whole and 3/4. Same thing. So 1/2 plus b equals 3/4. So how would I work from here? Well, they're still not equivalent, so I need to multiply by 2 to get my other fraction to become equivalent. So now I have 1 2/4 plus b equals 1 3/4. I'm going to do the exact same thing I did before. I need to get rid of everything except for the variable. The variable needs to be on one side. The whole number or the every other value needs to be on the other. So because I have a positive 1 2/4 here, I'm going to subtract it. Let's subtract it over here. Now my b comes down. So b equals 1, right? 4th. Why? These ones canceled out. 3/4 minus 2/4 equals 1/4. So we're multiplying by 2 because remember in our model how we know that if the denominators are not the same, we can't do anything with it. Like literally, when we represented them as models, they're not the same. So what we did is say, hey, we know that 2 can go into 4. So why do anything else besides make this denominator out of 4? So what do I multiply by 2 to get me to 4? 2. And if I do it on one side, I have to do it to the other side. Okay? Now, let me go a little deeper into that. Now, let's say you're not good with the greatest common factor, multiples. I'm going to give you what's known as a crisscross applesauce butterfly method. It's another algorithm, just steps you have to memorize. All right? So let's say we're talking about 2/5 and plus, let's just say 1/3. Okay. So one of the things that you can do is you can say, all right, so to make these the same, this is me using the standard algorithm, the butterfly method, just memorizing steps. I'm going to say, well, I know that 5 times 3 equals 15, and 3 times 5 equals 15. So this fraction is going to become out of 15. Because I know that 5 times 3 gives me 15. I know that 3 times 5 gives me 15. Right? So I multiplied these together. That got me 15. And if I do it on one side, I have to do it to the other side. So I can say, okay, well, now it's going to be 3 times 2, which is going to give me 6. And over here, it needs to now be 5 times 1, which is going to give me 5. Okay. You can always use this, kind of like a butterfly, crisscross. All right. You can always use this method if you do not know your greatest common factors. Okay. Again, we're all about passing. So play to your strengths. Stick with the algorithm if it makes it easier. Are we ready for another problem? Let me know in the live chat. Yes, if you're ready for another problem. If not, let me know what question you have. If you're all the way lost, you have no idea what is going on, please say that so that we can get everyone up to speed. All right. Heard from Ildi, heard from Lillian, heard from Mariana, heard from Vianza, Have not heard from Andre, Brandy. Yeah, let's move on. All right, go ahead and solve this one. Again, and then once you're done, go ahead and share your response. Again, I prefer a text so that the answer is not given away to everybody. But if you can't do that, use a live chat. Okay. All right. Looking good so far. Still waiting on a few more people. All right. Looks like everyone's starting to catch on. One person said they had a question. Okay. Okay. So I know Lillian has a question. Okay. So here's what I'm going to do. Most of you guys are doing very well with this. When we come back, we're going to do a little bit of a review with this. And we're going to move on to two-step equations. I'm going to send you a link for two-step equations so that when we come back, we'll come back the very latest around 11. This will give everybody a chance to work on two steps, and that's 2 math centers we're covering in a day. So please work on those. And when we come back, I'm going to address Lillian's question, and we're going to then work on two-step equations. All right. So see you guys no later than 11. I'll send another link out for everybody to join. So this will be your opportunity to get a bio break, check on the kids, all of that. All right. So see you soon.